Hey, all you skiers and snowboarders. Are we talking about slope in math? We are. Welcome to the Math Jedi Math Channel. Today we are tackling slope and everything, all the ups and the downs. That was funny. Here we go. So today we are talking about slope. And this always makes me think of skiing or snowboarding. So we're talking about slope. And basically, this is what I want you to envision. I'm trying to think of how I can color things. Let's see. Let's get a mountain. So here is our mountain. And one thing, if you're wondering which mountain is it, we'll say it's the mountain that I grew up learning how to snowboard on, Whistler, from good old Vancouver, BC. Vancouver, British Columbia. We hosted the Olympics in 2010. So yeah, it's a pretty good mountain. I was pretty lucky. And basically I want you to always be thinking of if you have a mountain that, and you're snowboarding, you're always starting here, and that if you're drawing it, that you are, so there's my little snowboard. Whee, there we go. And you're always drawing it from the left side going this way. Okay, so that's going to be really important in a second. Okay, so that's going to be the envision that we're going to be doing. So what is slope? I'm talking about snowboarding. What is it? It's basically looking at a line that represents hopefully something, some data. And that's what we're using in the real life. So slope is a line that represents data. So what does it actually look like? So this is what I'm talking about. So here's our little graph, right? So here's our x and here's our y. Our y-axis, these are our axes, right? We call these axes. And when we're talking about slope, here's two lines. So this is a, oops. Let's get some color in here, right? So this is a line. That's a line. And another line could be like this. And each one has a slope. And a slope is basically when you're starting to look at something called the rise and the run between them. So you see little dots I'm just kind of doing there in the different colors. So we're kind of looking at the slope of it, the kind of the angle. And in math, we say it's the change in y over the change in x. So that's what we're kind of looking at. And I'm going to teach you some different words that you need to know and also how to go and calculate it. So that's what we're going to be doing. So we're looking at kind of the steepness of lines. That's what we're going to be kind of looking at. So let's get into some definitions because that's going to really be helping a little bit. So let's get rid of that. Oops, do I have to get rid of that like that? Oh my gosh. That's not good. There we go. Okay. So, slope. I'm going to give you different ways that we talk about it. We say this in math. The change in y divided by or over the change in x. If you want to be really fancy, we say this. We use this triangle thing. Sometimes you'll see this. This just basically, oops, it just means change. So that's what it means. Okay, so that's kind of the same thing. That's one way to say it. The kid version of this is rise over run. When you rise, we're talking about the y's, and when you run, we're talking about the x's. Okay, and then there is the mathy formula where we say m is equal to y2. We call that y2. It's not y squared, because see the little 2 is in the very bottom kind of right-hand corner. It's like a subset over x2 minus x1. Now that's like, what are you talking about? So first off, m, that's usually the symbol or the letter we typically use, but we don't always use it. Sometimes we mix it up a little bit with other letters. So do realize that. But for the majority of times, we use M for our slope when we're talking about slope. I know. Why don't we use S? Because we're mathematicians. We want to make things a little bit more interesting. So we say M. Okay, so that's your definitions of slope. What other kind of things do you need to know about slope? So remember, we had this picture, right? So we need to know some different things about slope. So for slope, there we go. So a steep slope has numbers greater than 1. So greater than 1. Okay, so does that make sense? So maybe I'll draw some pictures afterwards. And I would say a gentle slope has numbers, you guessed it, less than 1. So I want you to think like fractions. So things like, 2/3, 4/7, things like that. We also have positive slopes. So this are slopes that go up. And you guessed it, we also have negative slopes. And these ones go down. I'm hoping you have some colors with you, because I do want you to be making some really, really cool. Here, I need to bring out my color wheel. Do you guys want to see how my colors come? My colors are Copic colors. I'm showing you some behind the scenes thing. So these are my Copic colors. If you're always wondering like where all my colors are coming from, this is where they all come from. So if you know Copic, basically these are like the tried and true colors that all the artists use. So I have a whole different variety of them. It's kind of cool. And I'm gonna go and have a graph, and I want to just kind of show you some things. So, okay, I'm gonna show you my steep slope. So my steep slope is gonna be something really, really steep. That's gonna look like this. Does that look like a steep slope? Yeah, for sure. And I'm gonna say, imagine that was like m equals, I don't know, 6. And then I got my gentle slope. I want to show you what a gentle slope would look like. So I'm going to give you an example. Here we go. Whoa, that was really long. So that's a gentle slope. And I'm going to say like that is where my slope is maybe 2/7. Cool. Now I'll talk about positive slopes. So positive slopes are slopes that go up. So here's my slope that's going to go up. So this is up, and I always like to have a little person walking. So that's always my visual. This person is walking up. Okay, so you're always walking left to right. So ask yourself, if the little person was on the line, on the slope, and they were walking left to right, are they going up? If they are, it's positive. And if they're walking left to right and they're walking down, like this, then it's negative. So if your little person is walking left to right and they're walking down, your slope is negative. So something like m equals, this would be like negative, I don't know, 2. And over there, that's just a positive slope. So you'd say like m is, I don't know, is it more steep or less steep than the yellow one? What do you think? I think it's a little bit less, so I'm going to make it a smaller number, like 4. Okay? So those are different kinds of slope. So you have positive and negative slopes. You have steep slopes and gentle slopes. And then, what else do we need to know? Let's go and take this away now. Don't need to know that anymore. Goodbye. What else do we need to know? We also need to know that slope is rate. So slope is the rate. Okay, so slope is the rate. And when you're thinking of rate, the most easiest example is when you're in a car and you're driving 50 kilometers in 1 hour. And basically, when you're graphing this, you're going to get a slope. Remember, this is your x, so this is your independent variable. Some science words. That's your hour. And this is your kilometers. So that's your dependent. And remember, as you're going up in hours, you're increasing how far you travel, right? And you start to get a slope, which is the rate. So as your rate increases, so by that I mean, let's say you went faster. You went super fast. 88 kilometers per hour. Is that how fast Marty McFly had to go? Was that the magic number? I think it was. Go check out your Back to the Future. And the what was the car called? I always forget what the car was called. I want to say Mandalorian, but I think it's something like that, isn't it? Anyways, so this one, you would have a steeper line because the slope is bigger. Also, this ties into what we've been kind of talking about with rate and ratios. This would be a unit rate. Don't forget, those are all unit rates. So there you go. That's kind of what we're going to be looking at. So slope. I'm hoping conceptually you have an idea now of what we're doing, because now I'm going to kind of get into the nitty gritty of how to go and figure out your slope. Because you got to be able to figure it out. Let's go and figure it out. There's going to be some different ways to figure out your slope. Oops. So here we go. How to figure out. The first way is the easiest way, and a lot of students always forget that. It's just to count. Can you all count? Good. Then you can do this. So just counting. So here I'm going to draw a really basic graph. So this is a 5 by 5 graph. So if you're taking some notes on some graphing paper, it's just a 5 by 5. I'm going to draw a couple of lines. First line is going to be purple, because why not? And I'm going to just make some really, really big points on this that are very obvious. There. Okay? I hope those are nice and obvious. I'm going to go and label these ones just so you know what point they are. So this is 5, 3. If you remember how I got that, the first number is the x and the second number is the y. So I'm starting it here at 0, 0, which is the origin. I'm going to go across 5, and I'm going to go up 3. And this one is at, of course, 1, 0. So now I wanted to just go and figure out what the slope is. And how do you do it? So you count the rise and you put it over the run. And you have to do it from 2 points. So you need to figure out what 2 points you want to rise and run from, okay? Sometimes they're given for you, like I'm giving them to you now. Sometimes they're not, and you got to go find them yourself. So these are the 2 points. We're going to calculate the rise and the run. So here we go. Let's go up, and look how I'm going to do it. 1, 2, 3. Okay, good. And I'm going to go across from here. 1, 2, 3, 4. Did you get that? So that's 4. And my rise was 3. I'm going to kind of write it right here. Hope you can see that. Okay. So what was my rise? My rise was 3. So here we go. it was 3, and my run was 4. So that's going to be my slope. So I would say m is 3/4, 3 over 4. Now I want to show you something that's going to be crazy. I'm going to use a different color. I'm going to use green because I like green. I'm going to go from this point, the exact same point, to this point. Why would you do that? Well, watch. Here we go. I'm going to go this way. Now, what way am I going right now? Which direction am I going? Are you all saying backwards? Yes, I'm going backwards. I'm going backwards how many? 1, 2, 3, 4. I'm going backwards 4. I'm going to say that is -4. And then I'm going to go down 1, 2, 3. I went down 3, which would be considered -3. So my rise was -3. If you're going down, it's negative. So if I kept doing that, if I kept going backwards 4, down 3, backwards 4, down 3, you're going to get like a staircase effect. But I wanted to show you that my rise was -3 and my run was -4. Remember, a negative over a negative is really a positive. So I did want to show that you could go from the different direction from the other points. You can be doing that. So counting is one way you can do it. Let's just do one more counting. Why not? Let's do... should I do it right over here? Yeah, sure. And I'm going to still do 1, 2, 3. I'll do it 3 by 3. 3 by 3. Okay. And I'm going to go like this. Imagine it was a straight line. So right now, if you're looking at the line, I'm going to show you this is the point I'm using and this is the point I'm using. I'll label them for you so it's nice and clear. This is 3, 0. And over here is going to be 0, 0, 1, 0, 1. We'll say. And right now, what kind of slope are you going to have? Positive or negative? I'm hoping you're saying negative because you see this, it's going down. You see it's going down? Yeah, it's going down right now. So it's going to be negative. So let's go and do our counting. I'm going to use yellow. Why not? So I'm going to count from this point to that point. Okay? So I'm going to go over 1, 2, 3. And I'm going to go down 1. So I went over 3 and I went down 1. So remember, it's rise over run. So how much did I rise? I rised 1. I rised -1, didn't I? Because I went down. And over here, I went left to right, so that's positive. Make sense? So my slope is -1/3. So far, so good. So that's counting. Just count between 2 dots, right? Sometimes you got to find your own dots. Not a big deal. Nice and easy. Okay. But what's the second way? Well, I'm glad you asked. The second way is using a formula. And you've already seen this formula. So the slope is equal to y2 minus y1 over x2 minus x1. Like, what is all this? What is all this stuff? Well, basically, I'm going to show you. Here is your graph. And I'm just going to... oh, okay. Let's make it a 4x4 graph. Let's just make this the best example ever. I'll give you only one example today. Because you're going to get lots of practice in class, right? Your teacher's going to give you lots of practice. And as all good teachers should, right? Let's say this is the... Oh, that's a good line. That was a... What was that? I don't want that. Get that away. Bing. There you go. So here's the dots that I'm going to be using, okay? Actually, you know what? I don't use that one. Let's use this one. There's a reason why. I'm going to tell you what these numbers are. So this one here, we 1, 2, 3, 4. So this is -4, 0. And this one is 2, 3. We'll say it's 2, 3. You could probably argue it's not, but we'll say it's 2, 3. Okay, so step 1. So how do we do it? So step 1. Step 1 is label them. So I'm going to go and label these. I'm going to call this my very first point. So this is point number 1. Okay, you can make the other one point number 1 if you want to, but I'm not going to. So this is going to be my very first X, and this is my very first Y. I'm going to make this point my second point, which means that's my second x and my, let's put it up there actually. Oops. There we go. This is my second x and my second y. See what I've done there? Great. Now, that was step 1. So step 2 is plug in the numbers. So I'm going to plug them in, and I'm going to be plugging in the numbers right now. So let's go and plug in the numbers right now. And remember, I'm going to kind of draw it like this because it's going to be nice and easy. So notice I'm doing the exact same thing as I did over here, right? So I'm just putting brackets around what my y2 and y1, x2 and x1 will be. And I'm going to use colors to go and fill them in. So y2, where's my y2? So my second y, there it is, it's a 0, so I can put a 0 in here. And my y1 is here, so I can put in a 3. Cool, x2 is right here, it's -4, and then 2. Great, let's go do the math. What's 0 minus 3? It's -3. And what's -4 minus 2? That's going to be -6. This is a negative over a negative, so that's going to be a positive. I'm going to simplify it as well. So that's going to be a positive 1/2. So that is what my slope is going to be. I'm going to say it's m. So that's how we go and use a formula to plug things in. Sometimes teachers will also give you a question where they just will say this. This is what they say. This is the question. So one more example. They're going to say, what's the slope between the 2 points? So what's the slope, and there you go, between 2 points? And the 2 points, they'll give you the 2 points. So they'll say the points are 7 and -2. And maybe the other one would be, I don't know, 4, 3. Okay, I don't know. They're asking what that is. And what you do is you go and you label them. So I'm going to call this, these are my first points. So this is my first x and my first y. This is my second x and my second y. Okay, and I'm going to go and plug them into that little formula. Remember that formula was y2 minus y1 over x2 minus x1. Okay, so I'm going to go plug those in. And yeah, I like to use brackets to start things off, because when you use brackets, you don't make mistakes, and I don't like making mistakes, so I like to use brackets. I'm also going to show you something that does pop up for this question in particular. I chose some special numbers. So y2, so 3, and then my other one was -2. And then x2, so 4 and 7. Cool. So this is why I went and chose those numbers. You can probably guess why right now. 3 minus -2. So what does minus become? It becomes plus. So this is really 3 plus 2. So that's 5. And 4 minus 7 is -3. There, that's your slope. Done. 5 over -3. Hey, are you wondering what that looks like? You are? Okay, well, I'm going to go and just quickly draw it. So this is like 7, -2, and this would be like 4, 3. It'd be like that. So it's pretty steep. Oops. It's pretty steep, and it's obviously negative, right? Because it's going down. And this is a pretty steep slope, isn't it? It's greater than 1. It's greater than a negative. It's greater than a -1, so it's gonna be pretty steep. And yeah, that's what it kind of looks like. So there you go. This is your first lesson all about slope. Hope you enjoyed. All right, thanks for sticking with me through all of that. Again, the ups, the downs. Oh, math is such a journey. I hope you enjoyed it. Go subscribe, share, tell all your friends about it. Put it on TikTok, social media, everything. Let's get the subscriber count up. Until next time, all you Padawans, have a great day.